Relative velocity. What's relative velocity? It's when you have two objects moving at the same time with different speeds. Okay? So I'd like you to use your imagination. You're traveling down the freeway at 100 kilometers per hour. When a white Escort hurtles by you, blue smoke and all, at 140 kilometers per hour. Well, no. On the ground, if someone was standing still, they would see you traveling at 100 kilometers per hour and the Escort traveling at 40 kilometers per hour. But if you're going at 100, even though the Escort's going at 140, it doesn't pass you that fast. You perceive it as going, relative to yourself, 40 kilometers an hour. You perceive its difference in speed or velocity compared to you, relative to you. It's why we call this relative velocity. And it turns out, in physics, one of the reasons that Einstein used the word relativity to describe two of his main theories is he was onto something in that everything is relative. There is no problem with you deciding if you're on the freeway, Kyle. You can either do the physics saying you're traveling at 100 kilometers per hour forward, and all the physics works. You can equally say that you're standing still and the Earth is rotating at 100 kilometers per hour backwards underneath your tires, and all the physics works there too. There is no way in terms of physics to prove who's right and who's wrong. It's just that conventionally we assume the Earth is standing still and all of us are moving on it. The relative velocity of any moving object depends on your point of view or frame of reference. In fact, you see the car moving forwards at 40 kilometers per hour. What does the driver see? If he looks in his rear view mirror, he actually sees you in reverse at 40 kilometers per hour. That's what it looks like to him, because it looks like you're backing away from him. You're receding in the distance. And that is perfectly fine mathematically and in physics. You can say that, and there is no way to prove that he is wrong. There is no way to prove that there is a frame of reference in the universe that is, fancy word, absolute, that is correct. Everything is relative. Here's an example. A zebra is running away at 50 kilometers per hour forwards. And he's running from a cheetah going at 90 kilometers per hour. This could end badly, or this could end well, depending on your point of view, much like the velocity. What velocity does the zebra see the cheetah going at, and vice versa? So from the zebra's point of view, the zebra sees the cheetah traveling at 40 kilometers per hour forward. That's its net speed. From the cheetah's point of view, as he's running, he sees the zebra getting closer and closer. It's as though the zebra is traveling backwards towards him at 40 kilometers per hour, or negative 40 kilometers per hour. With me so far? Okay, let's try applying this then. If the zebra starts out 90 meters ahead, how long will it take until the cheetah catches up? Okay, what's this question asking me to find? Now, I'm going to say this, Noah, and eventually well, actually not even in Physics 12, in university this will change. If I give you a relative velocity question and you'll be able to tell Amy because there's two objects moving, right now, at this stage in your physics career, you can assume that. I'm not going to give you a question, Kyle, and also throw in some acceleration. Well, we can handle it, but that's overkill. What else have they told me? What's that there, 90? And what I'm going to use for this is my relative velocity, and the abbreviation I use for relative velocity is VREL. What's the relative velocity in this question? It's not 50, it's not 90, it's what? 40. How long will it take, it asks, until the cheetah catches up? I'm looking for an equation that has dA V and T in it. I think this one. It's good to know you have a friend, but tell him to shut up and sit down. Is that okay so far, Cade? Yep. Now, Cade, I can see you're frowning a little bit. You probably saying, Mr. Dueck, this says VI. This is not V initial. Wait a minute. Cade, what's my acceleration in this question? So what can you tell me about V initial and V final and V middle if my acceleration is 0? All of those V's are going to be what? The same. Okay, so it says VI, but that's going to be V rel or V middle or V final, or as long as my acceleration is 0. And in fact, woohoo! Right? What are we trying to find? Time. How would I get the time by itself? Sorry? Divide the V. So here's yet another equation. Time is going to be distance divided by, and now I'll put a little rel there to remind myself that's the V I'm going to use. Not that you really need to, but I'm always paranoid. I want to avoid making mistakes. Now I got a problem. I got a bit of a problem besides the knock at the door. What's wrong with this question? Can you put it in block A? Thanks, Jake. Ready? Look up, look up, look up, look up. Right? What's wrong with this? Units don't match. And I am going to give you at least 1 or 2 questions on your test where I'll give you the speeds in kilometers per hour or the distance in kilometers, and we got to do a conversion. In this case, it's they gave me the speed in kilometers per hour. Now, we haven't done this for a while. Who remembers how do we convert from kilometers per hour to meters per second? It has something to do with the 3.6. It is divide by 3.6. So I have to do a conversion here, 40 divided by 3.6. And I get 11.1111111111. I'll write 11.1. That's the speed in meters per second. So I'm going to get this. 90 divided by 11.111111, but I'm going to use the answer button on my calculator. And I get 8.1 seconds. Hours? No, seconds. We converted it to meters per second. And then the whole predator-prey circle of life comes in, because in this question, the next question we would ask is, well, how long can a cheetah sprint for? If it's more than 8 seconds, lunch. If it's less than 8 seconds, the zebra might be able to get away. And that is the balance that the thinner, lighter gazelles and zebras that can run pretty fast are battling with the cheetah. The cheetah basically generates so much heat it can sprint in short bursts, but if it doesn't catch it real quick, it's out of luck. And it's also wasted energy. So it's always, that's why when you watch the nature shows, you may see, oh, there's a cheetah walking really, really close to those zebras, and the zebras aren't running. The zebras have done the physics in their heads, and they know about how far away the cheetah needs to be before it's got a chance at catching them, and the cheetah knows the same thing, so it's not going to waste any energy. Right? I'm assuming you've all watched the Odd Nature show, right? Example 2 says, state the relative speed in each case. So here we have trains. Let's say they're 2 trains or something. What's the relative speed in this first case here where they're both going at 40 kilometers per hour? Meant to be really obvious. Yeah, Spence, what? 0. Relative velocity or relative speed, 0 kilometers per hour. What about here? 20, okay? I'm going to go 20 kph. Now, really, it's 20 kph for this guy, negative 20 kph for this guy. The guy in the back sees the car coming towards him backwards, backing towards him, because he's catching up. Ooh. What about here? Yeah, trains and the spectacular collision. What's the relative speed here? I heard someone whisper it. They were right with their guess. Maybe I didn't hear someone whisper it. I thought I did. 60. Yeah, 60. And that's going to be the secret to dealing with two moving bodies. We're going to say, you know what? No, they're not both moving. We're going to let one of them, we're going to pretend mathematically, Kyle, that it's perfectly still. And we're going to use the relative velocity for the other one. By the way, are you guys standing still right now? Yes or no? Well, the answer is mathematically we treat you guys like you're standing still. But is the Earth standing still? Okay, it's spinning. Not only is it spinning about its axis, it's also revolving around the sun. It's rotating around the sun. Not only that, the sun itself, the solar system, is moving through the universe at a pretty high speed. Not only that, our galaxy is moving through the universe at a pretty high speed. But this is what Einstein showed. It's all relative. And you know what? It doesn't matter. You can let mathematically position 0 be wherever you want, and the physics will work from there. But there's no way to prove that you're standing still or that you're moving. Wait a minute, you just said we're moving. Well, no, actually, you could say that you're standing still and the universe is rotating around you. And you know what? You can do the math that way just fine. It's uglier math. Most of the time, the decisions we make are based on which gives us the cleanest math. And the cleanest math is, let's pretend you're standing still, we'll ignore the Earth. Okay? So what kind of questions might I ask? Well, I like this question, I like this question, I like this question. Example 2 says this. How long does it take these trains to completely pass each other? Okay. What's this question asking us to find? Time. And I wrote here, since both trains are moving, this seems like a difficult task. I mean, the longer train is eventually going to catch up to and then pass the shorter train, but we don't know how far both of them will travel during this time. They're both moving forwards. Or are they? We're going to pretend that the slower train is standing still. Okay? First of all, looking at the picture then, what's the relative velocity of the bigger train? 7? I disagree. I think you thought it right, but made a math mistake. How fast is the bigger train traveling? Okay, 8. Can we go with 8? Yes? Right? 13, 5, 8 meters. Are they heading towards each other in the same direction? So we'll subtract. Okay? 8 meters per second. And again, to be really, really fussy, Danielle, to the big train, it's -8 because he sees the small train coming towards him. Small train is positive. I just want the relative velocity. 8 is the difference. And the other thing, to me, for the big train to pass, I think here's what has to happen. This back corner here has to pass the front corner here. How much distance is that? Now, I realize they're moving forwards. I don't care. I'm going to pretend everything is standing still, and mathematically, with relative velocity, I can do that. How far will the back train have to travel to get its back corner past the front corner of the front train? You already told me they're asking us to find time. And remember what else I said? You can always assume if it's a relative velocity question, A is going to be what? We're going to go constant speed for these. By the way, it really wouldn't be that much more difficult to have an acceleration in there too, but whatever. I'm looking for an equation that has those in it. Why, once again, I think it's going to be Once again, I can do that. Why can I cross that out? A is 0. Oh, wait a minute, Mr. Dueck, you wrote V initial. Yeah, if acceleration is 0, what can you tell me about V initial and V final and V middle and V relative? Same thing. Okay. Spence, how do I get the T by itself? Okay. Oh, sorry, D equals, Mr. Dueck? T equals. So it's going to be 250 divided by 8. Can I do that in my head? It's going to be 125 divided by 4, 6.25, 3.125? Am I off? I think I'm off. 31.25? I was off by a decimal. I had the, yeah, okay, 31.25 seconds. Well, it looks like they went 3 sig figs and everything, so technically 31.3 seconds, right? That's 3 sig figs, that's 3 sig figs, that's all 3 sig, so we'll go 3 sig figs. So there's one kind of question you could ask. Another question might be, instead of finding time, what else? Well, let's see. Here's another time question. Example 3. Yeah, turn the page. How long does it take for these two trains to completely pass each other? Well, Noah, what are they asking me to find here? Time. Let's write down T equals question mark. Now, it seems to me to completely pass each other, the back corner of this train has to get past the back corner of this train. That's when they completely pass. So, how much distance are we talking about? How will I figure out the distance? You see it? No? Yeah? Pardon me? How? How will I calculate it? It's going to be 120 plus 80, the length of the two trains, plus how far apart they are. Which is what? 460. Someone want to double check? It is 460? Ah. What's the relative velocity in this case? Give you a hint. Not 4. Max. Well, oh yeah, they're heading towards each other. And again, mathematically, we're just going to pretend one train is standing still and let the other train do all the motion, and we're good. 16, and A is 0. Oh, this is getting repetitive. I think we're going to end up with T equals D over V. 460 over 16. 28.75. I'm going to, you know what, 3 sig figs. I'll go 28.8 seconds. Hey, that's what the answer said it was. Yeah. Mr. Dueck, can you put the answers on tests? No. Sorry? Yeah. Okay. So I figure on your test, it's fair game to have one vehicle being passed and say, find how long, or have them coming towards each other and say, find how long. Sorry, I moved the one train up, Jordan, no head-on collision. I know you kind of wanted, but anyways, they're going to pass each other safely, no carnage. Let's talk about speeds a little bit here. I always like to, whenever I give a concept to students, help them develop a gut instinct as to whether their answer is close or not. I like them to know what's big, what's small, roughly, so that you can catch calculator errors. And in fact, by the time you get to Physics 12, You know, a lot of my friends, Mr. Dueck, I'm doing this, and I'm pretty sure the answer is way too small or way too big. To me, that's a great habit to get into, Kyle. You don't just trust your calculator, you analyze it. So I made a chart here. We're going to mix and match speeds. I have a bunch of speeds on the right. I have a bunch of situations in the middle. We're going to try and fill in the blanks on the left. Scan that list. What's the fastest thing in the middle column there? Light is actually the fastest thing in the universe. So on the right, what's the speed of light? What's the fastest speed in the right-hand column there? 300,000 kilometers per second. So let's write that here. 300,000 kilometers per second. And let's cross out this one. Oh, you know what? The one right below light, car on a city street, I know that one too. What's the speed limit on a city street for a car? Find it on the right-hand side there. Which one has it got to be? Okay, 50 kilometers per hour. I can fill that in. And, you know, I think I can do the next one. Formula One race car. But you know what? Let's come back to, sorry? 220 kilometers. Would it be 100 kilometers per hour? Well, no, because what speed is that? That's freeway, and they go faster than that. 55 meters per second. I don't know what that is in kilometers per hour. Oh, I could figure it out, though, because if I divide by 3.6 to go from kilometers per hour, pardon me? 55 times 3, it's about 150. 55 is not that fast. You know what? I think I'm going to go with the 220 kilometers per hour. Okay. By the way, what does the U.S. measure their speeds in? Miles per hour. Rough rule of thumb, if you divide meters per second by 2, that's roughly miles per hour, very roughly. In other words, 55 meters per second, it's around 25 miles an hour. Yeah. It was 2. I think it was 3, but which one gave it up now? Bangladesh or something gave it up. I had that video that I showed you guys at the beginning of the year. One of those countries has now gone metric. Yeah, it's the U.S. being the U.S. Okay. Well, you know what? Let's start at the top. Human walking. Yeah, I think about 4 kilometers per hour. That's a slow walk. Okay? Fastest human running. Okay, so how far does Usain run? 100. In approximately what time? 10-ish. So what's his speed? Yeah, 10 meters per second. He probably gets a little higher towards the end because he has to start from 0. But yeah, it's tough to run much faster than 10 meters per second. If you're getting faster than that, you've got some serious speed. Hey, what do you think that 3,600 kilometers per hour goes with? Top fighter jet, I think. Okay. We got sound, we got fastest animal, and we got terminal velocity human. By the way, what is the fastest animal? Cheetah, land animal. Yeah, cheetah. Birds, a couple of birds that can go faster. I don't think there's any ocean creatures that go faster than that, but I'd have to double check. Tunas are pretty fast. They're all muscle, which is why people like to eat tuna as well. Which of those do you think is maybe a cheetah speed? 100. See, I know growing up, I always memorized cheetahs can go 60 miles an hour because I grew up pre-metric. We went metric when I was like 7. That's when Canada switched over. So I still have some of the old imperial units, and 60 miles an hour is freeway speed. And I know cheetahs can run freeway speed, and 100 kilometers per hour is freeway speed. So yeah, let's go with that. Which of these is the speed of sound? Yeah, in fact, honestly, I have always memorized the speed of sound as being 333. It's not quite, but I always remember it's 333. Speed of sound varies depending on height, time of day, temperature, how much moisture there is in the air. But yeah, 330. So what's terminal velocity for an average human being? When I jumped out of an airplane, I mentioned I jumped out of an airplane. How fast was I traveling? 55 meters per second. By the way, multiply that by 3.6 real quick. What is that in kilometers per hour? 100, yeah, 200 kilometers per hour. If I hit the ground at that speed, is that terminal? Yeah, the terminal velocity isn't meant to be a pun. It's terminal velocity because your speed, your acceleration is terminated, but it's almost always fatal. And there have been people that have survived, though, too, but always with massive injuries, right? So that gives you an idea of, sorry? Yeah, there was, as I understand it, there was a Russian passenger jet that had an explosive decompression and a stewardess got sucked out. And she did survive from something like 20,000 meters, but she landed on the slope of a snowy mountain hill, which cushioned things. And I'm going to say that she survived. I mean, her heart kept beating, and I think her brain was functional, but she never walked again and had, permanent damage. But she was alive. I think that's the record, but I got to go check. I have a book called The Flying Circus of Physics that has all these little trivia in it. I keep meaning to add them to the lessons. Hey, I got a Pro D coming up. That's what I can do. Of course, by then I'll have done this lesson, but I can add it to the other ones. Okay. What's your homework? Well, number 1. What are they asking you to find in number 1? Time. Number 2, time. These ones I haven't quite talked about, but I'm curious to see if you can figure it out. Certainly number 1, just find the relative velocity. Number 2 is saying find time. Number 3 here, first of all, in number 3, you'll have to convert things to meters per second and then unconvert to kilometers per hour. Here, I'm giving you the time, and I'm instead asking you to find the final velocity. I like number 3. I like number 3. I like number 3 because it's kind of a cool question. I haven't talked about number 3. I'm curious to see, Noah, who can figure it out. Start out the same way, DFIC. They want me to, by the way, what this wants you to find is V relative. And then once you find V relative, you have to add it to the cops to figure out how fast the cops are actually traveling because they're not standing still. Number 5. I skipped 4. Okay? Also the take-home quiz. So looking at relative velocity, I got some cool videos.